Okay, so let's take a look at translations. Now, a translation is a type of transformation that actually maps an original figure called the pre-image onto a new figure called the image. So if you look at this diagram here, A, B, and C, or triangle ABC, would be considered the pre-image. And A prime, B prime, and C prime would be the image here. So those little apostrophes here, we read that as A prime, B prime, C prime. That always denotes your image or your figure after it has been translated. Now what a translation does, it actually slides a shape a fixed distance in each direction without changing its size. So if you look here, the pre-image has been shifted to the right and it also has been shifted down, but it did not change the size of the image. Now a translation is a rigid motion, and a rigid motion is when a transformation preserves the size and shape of a figure. All corresponding sides and angles of the pre-images and images are congruent. So as you can see here, this image or this pre-image has shifted to the right and down, but again it did not change in shape or size. It simply moved across and down the coordinate grid. An example or examples of rigid motions are translations, reflections, and rotations. All right, so now let's look at this problem here. For the coordinate notation, we have the ordered pairs, and when we translate, the ordered pairs are x plus h and y plus k. And h denotes our horizontal shift or left to right shift, and our k denotes our vertical shift or our shift that is up and down. So we could say that x would be our x value of our coordinate or our ordered pair, and the y would be the y value of our ordered pair. So now if we look here, the first thing we want to do, so it says graph the image of the figure under the given translation. So this is our image here, all right, and this is triangle with vertices C 2, -1, D 7, -4, and E 4, -6. And we want to translate this image x minus 3 and y plus 8. So basically 3 units to the left and 8 units up. And the way we do that, we simply take each ordered pair, all right, so each vertice of our pre-image here, and since that is a -3, we are simply going to subtract 3 from each of our x values. So I'm going ahead and just put -3 above each of our x values, and then we're going to just add 8 to each of our y values. All right, and so our image, so our C prime, so we have 2 minus 3, that gives me -1, and then we're going to have -1 plus 8, that gives me 7. I'm going to go ahead and plot that. Start at 0 on our coordinate grid, so back 1, or to the left 1, and up 7. 1, 2, 3, 4, 5, 6, 7. And I'm just going to draw that point there, or plot that point, label that C prime. Then I'm going to complete the calculations for D prime. So 7 minus 3 will give me 4. And -4 plus 8 will also give me 4. I'm going to plot that. starting at 0, going to the right 4, 1, 2, 3, 4, and up 4, 1, 2, 3, 4, and that is D prime. And go back for my E prime, subtracting 3, so 4 minus 3, that is 1. And negative 6 plus 8 will give me 2. I'm going to plot that. To the right 1 and up 2, 1, 2. So my E prime here, and then I will just simply connect my points. Trying to draw a straight line here. All right. But as you can see, we've translated this figure 3 units to the left and 8 units up. We've translated that figure. All right, so I would like for you to try this one. You can try this one on your own. Go ahead and pause the video and try it on your own. We want to translate this trapezoid x plus 7, so that would be 7 to the right, and y minus 9. So see if you can do that on your own. Go ahead and pause the video and try it on your own. All right, so hopefully you paused the video, and this is what you should have gotten for your answer here. S prime 4, negative 3, T prime 7, negative 2, and U prime 8, negative 5, and V prime 2, negative 7. So you would simply just add 7 to each of your x values and subtract 9 from each of your y values. Okay, so now we're looking at identifying and writing rules. So we already have both our pre-image and image on our coordinate grid here. So I'm going to go ahead and just label this as pre-image. And again, I know this is the pre-image because it does not have the prime behind it. And so P prime, Q prime, and R prime is our image. All right, so the first thing I want to do to find a rule here is I want to write ordered pairs for my pre-image. And then after that, I'm going to find the ordered pairs for my image and then see how the two ordered pairs relate. So P prime, not P prime, just P for my pre-image. So the ordered pair for P is negative 5, 5. The ordered pair for Q is negative 1, 5. And the ordered pair for R is negative 6, 0. All right. So now I'm going to find the ordered pairs for my image. So P prime, that is negative 4, negative 2. Q prime, that is 0, 2. So I'm just going through writing each ordered pair. That's actually 0, negative 2. And R prime, this ordered pair here is negative 5, negative 7. Now, I want to actually write a rule here. So I'm going to start out by putting X and Y. That ordered pair translates, or each ordered pair translates X. And we're going to see what happens to our X values. So if we look at our X values, so from negative, our pre-image is negative 5 to negative 4. Negative 1 to 0. Negative 6 to negative 5. What is the pattern here? The pattern is that each of my x values are increasing by 1 unit. So from -5 to -4, that increases 1 unit to the right. From -1 to 0, that increases 1 unit. And -6 to -5, that increases 1 unit. If you could not see that, you could always just subtract the pre-image values from the image values. And just to show you, just going to write it up here. So my x value for my image is -4. -4 minus -5. It's going to change to plus. That gives me 1. If I do the same thing, 0 minus -1 for my q prime to q, that's just going to give me 1. So if you can't quite see the pattern there, you can always just subtract your pre-image from your image. But I can see that my x value is increasing by 1. All right. So now let's look at my y value here, or my y values. So from 5 to -2, what happens? From 5 to -2, that actually decreases by 7, or goes to the down 7 places. From 5 to -2, again, that's back or down 7. And then from 0 to -7, again, decreases by 7. If you cannot see that, again, let's just try it up here. If we subtract -2 minus 5, that gives me -7. And so my translation is y minus 7. And this is my answer here. So to write a rule, you need to take each of your ordered pairs, or you could actually just take one of them. But I always use at least 2. I did all 3 just to show you an example. But you can just take at least 2 of those ordered pairs and see the pattern. What happens from your pre-image to your image. And as you can see here, each x value increased by 1, each y value decreased by 7. All right. So on the next slide, which is this one right here, I would like for you to try writing this rule on your own. So describe the translation that maps each pre-image to its image. So go ahead and pause the video and try it out on your own. All right, so we have the answers here. I did all of the ordered pairs for each one, for the pre-image and the image. And so as you can see here, from -3 to 4, that increases by 7. 0 to 7, that increases by 7. Therefore, my rule here was x plus 7. And then for my y values here, 3 to 7, that increases by 4. 2 to 6 increases by 4. -3 to 1 increases by 4. So my rule for my y value is y plus 4. So I hope you got it correct. All right, so we've come to the end of our lesson, or our tutorial here. I have other related videos on reflections, rotations, and dilations in this transformation series. So if you want to learn more about transformations, watch these related videos. And if you want to learn more math content, please subscribe to this channel, share and subscribe, and click the bell so you can get notified whenever I post a new video. Thank you for learning with me.